Right. Example 1 says two identical. They will always be identical. Two identical point charges, but the charge on them won't be identical. Of plus 3 nanocoulombs and minus 5 nanocoulombs respectively are 2 meters apart. Determine the force between the charges. Also state whether the force is attractive or repulsive. If we have opposite charges, the force will be attractive. So, the force, the charge 1 will be plus 3. What's a nanocoulomb?
Times 10 to the negative 9.
Times 10 to the negative 9 coulombs. That is Q1. Q2's charge is negative 5 times 10 to the negative 9 coulombs. So calculations are always done in coulombs, not nanocoulombs or microcoulombs or picocoulombs. We have to convert the charge. And the distance between the two charges, their centers would be what? 2 meters. So the formula is F equals
K, Q1, Q2 over R squared.
This is now K. Please don't guess. I often find people writing the wrong value for the constant. Just put your eye on your data sheet and get it from there.
9 times 10 to the 9.
Times 3, 10 to the minus 9,
And then
times 5, 10 to the minus 9.
And then R squared is just distance, not radius.
No, it's not radius, it's the distance between the centers of the two charges.
2 squared. We use meters.
You use meters, yes.
The answer is 3,375.
Sorry, what did you say?
3,375 times 10 to the negative 8. Coulombs, I think?
What?
Oh no.
Newton's meter squared.
What?
Rags came.
You break my heart!
Newtons per meter squared. No, Newtons times meters.
Shit.
Okay, Berties.
Yes.
Is this where that one where you said we should ignore constant when you substitute?
Yes. You don't substitute negative 5, you substitute 5.
Okay.
So if we don't use that calculation from now, so the Q1 plus Q2 over 2.
It's completely possible, yes.
How would you use it if you were stuck? Remember?
Don't if.
Okay, like this is.
No, Tina, wake up.
Times 10 to
No,
the negative
wait, but I'm asking
51.
for help, but you're not helping me.
Times 10 to the negative 51.
You need to read the question.
No, I did read the question.
for 2A and 3,304.
So the first part of the question asks for the electrostatic force, so you need to use Coulomb's law. And the second part of the question asks for the gravitational force, so you need to use Newton's law. Between two electrons, so the charge on an electron won't be given, it's given on the data sheet. What is the charge on an electron?
9.11.
No,
What?
That's the mass of the electron. It's 1,6 times
1,6 times 10 to the minus 19 coulombs.
Yes, ma'am.
Okay, so you use the charge on an electron to calculate the electrostatic force. And you've got coulombs, you've got the constant on the data sheet. You don't have to miss it. They say the distance between the two electrons is 10 to the minus 10 meters. So I don't know what you don't understand there. And then with B, they say calculate the gravitational force between the two electrons. So you need to use the mass of the electrons. Where will you find the mass of the electron? On your data sheet. Where will you find the universal constant? The data sheet. So do we have values here? Can I have its 2 point?
304 times 10 to the negative 8.
Newtons, and that's a force of repulsion because the electrons are like charged. And the force of attraction, gravity will always be attraction.
5,5 times 10 to the
Sorry.
5,54 times 10 to the negative 51.
Which one?
4B.
Yeah. I didn't get that.
I didn't get that.
What did you get? 6, yeah, I also got 6 something.
I got 6,67.
Yeah.
One bit like our God is right, man.
5.54.
Yes.
Use your Casios correctly.
Ma'am, I have exactly that on.
Alright, I'll take my Casio.
That's
Sure.
right. That's correct.
Calculate the masses of substances. So with example 3, they say 3-point charges lies on a straight line. Take your pencil and draw a straight line. Okay? And you've got 3-point charges. Point charges just means that they are very small charges. So it's point charge 1, point charge 2, and point charge 3. They have charges of plus 2. So it's plus 2 nanocoulombs. And minus, is it plus 1?
Plus.
Plus 1 nanocoulomb and minus 3 nanocoulomb. Okay.
2 centimeters.
Q1 and Q2 is 2 centimeters apart. 2 centimeters. And Q2 and Q3 is 4 centimeters apart. I see 2 challenges right now. I see the challenge in that you are going to forget this is 2 times 10 to the minus 9 coulomb.
Why is that a challenge?
No? And this is 1 times 10 to the negative 9 coulomb. And this is minus 3 times 10 to the minus 9 coulomb. That's the first challenge I'm going to see. And the second one is that this must be in meters. 0.02 meters. 0.04 meters. The second thing I see is that you're going to forget where you are. So, meaning the following. Calculate the magnitude and the direction of the net force on Q2. So we're standing here. This is where we are. This is where we are.
Big legs.
What is 1 doing to 2?
Repel.
Okay. So I'm going to draw 2 and I'm going to say this is the force of 1 on 2. It's very important that we do this. What is 3 doing to 2?
Attracting.
So it's an arrow in the same direction. The force of 3 on 2. These two forces together makes a net force. What is the net force is the question.
So you plus
Wait. If the two forces are going in the same direction, I choose that direction as my positive direction. So the same direction. The forces are on 2 are in the same direction. So it is essential to draw a free body diagram. Yes.
Can I ask, how are they going in the same direction?
push forward.
Where are you standing? On 2. So I'm standing here. What is 1 doing to me? What is pushing me away? Where is it? In which direction? Left or right? No!
How's it
What's 1 going to do to me?
Pushing you to
Oh my.
Pushing me to the left. Okay.
To the right.
What is
Our-
3
that
going
your
to
left
do
is
to
our
me?
right.
That's what I'm saying.
No, it's chanting.
It's attracting. In which direction is attracting?
To the right.
Let's say if you
Her.
and Uko pushes you away. If she pushes you away, and I pull you. Which direction
Well,
is
that's not
it?
the same. That's not
It is the same.
You this side. Uko's standing here.
So
I'm
that's
pushing you
referring
pushing
to
you,
this,
and I'm
and
pulling
that
you.
is
Which direction
attracting
is
to
it?
this.
Oh, that way.
Exactly.
Oh,
Alright. You got it figured out. It's the tricky thing. Okay. So I know I'm going to use F net equals F1 plus F2 of F1 on 2 plus F3 on 2 because they are acting in the same direction. Very confusing, but if you draw your free body diagram, nothing will be confusing. Okay? So do you want me to do it all in one or separated? Okay? So the force of 1 on 2, and don't be afraid to label things. Okay? The force of 1 and 2 is K Q1 Q2 over R squared. K is 9 times 10 to the 9. Q1 is 2 times 10 to the minus 9. Q2 is 1 times 10 to the minus 9. And the distance is 0,02 squared. What do we get the value of that?
4,5 times 10 to the negative 5 Newton repulsion.
Right angle triangle.
And if 3 on 2 is,
K, Q1, Q3.
yeah, Q2 over.
No, oh yeah, Q2, 3.
So this is 9 times 10 to the 9 times 1 times 10 to the minus 9. I don't have to write the 1 times there. Times 3 times 10 to the minus 9. And this is where you'll pick up trouble if you substitute negative 3. Why some people don't listen to me? You are not the only ones. I find every single year people not listening to me, then they suffer the consequences. Okay? So what is the magnitude of the force that 3 exerts on 2?
1.69 times 10 to the negative 5.
To the right.
Now here you can see to the right. So F net will be F1 on 2 plus F3 on 2. So I need to add those two values, 4.5 times 10 to the minus 5 and 1.69 times 10 to the minus 5. What do we get?
6,19 times 10 to the negative 5 attractions into the right.
Here you won't say attraction, here you say to the right. So in example 4, we have three charges that forms an angle of 90 degrees. So we've got charge 1, 4 microcoulombs, charge 2, 6 microcoulombs is 50 centimeters from charge 1. So that distance there between them is 50 centimeters. And the distance between charge 1 and charge 3 is 30 centimeters. So that's where your 90 degree angle is. Right. Now they say, calculate the net electrostatic force on charge 1 due to the other two charges. So where are we standing? We are standing on charge 1. This is where we standing.
So ma'am, if you draw this picture wrong, it might mess up the whole thing.
But they're going to give you the picture.
The picture will be given, but the free body diagram is what you need to figure out. And if you don't figure out the free body diagram correctly, you will get things wrong. Yes. So we're standing on charge 1 because they want to know what is the net force on charge 1. So what is Q2 going to do to Q1?
Repel.
In which direction is repel?
Upwards.
Upwards. So what I'm going to do is I'm just going to draw this thing down a little bit so that I'll have space. So there's 1, and the force of
2 on 1.
2 on 1 is in that direction. What is Q3 doing?
Attracting.
Attracting.
To the right.
So Q3 is going to pull to the right.
F3 on 1.
Yes. Okay.
Now,
Okay. Just to finish the picture, they want us to get the resultant. What's the direction of the resultant? Where is the resultant going to fit in?
northeast.
Well, you can't say northeast, but I
Upright.
hear what you're saying.
Upright.
That is where if net will be.
Why?
Because that's the way it is.
Come on.
It's from tail.
This is the same one.
If you add these vectors head to tail, then the following will happen. You'll have,
This is the free body one. That's why.
yes,
And you can use
I don't even
Pythagoras.
you can use Pythagoras, yes. That is what the direction of it will be. You can't listen and talk. So if you add the vectors head to tail, the resultant will be that one.
That's why I was confused. Thank you.
So this is F2 on 1, that is F3 on 1, and this is F net. So obviously there'll be some other angle that you'll have to calculate. Okay. So the first thing we need to do is to get the force of 2 on 1. And we use Coulomb's law. Okay? Q1, Q2 over R squared. K is 9 times 10 to the 9. Q1 is 4 times 10 to the minus 6. And Q2 is
3 times 10.
6 times 10 to the minus 6. And the distance is
0,5 squared.
0,5. And that needs to be squared. So you get your
0,864 newtons upwards. It's given.
Okay, then if 3 on 1 is 9 times 10 to the 9 times 4 times 10 to the negative 6 times 3 times 10 to the minus 6 divided by
0,3 squared.
0,3 squared. And this gives us
It's 0.3. It's 6 over 5, which is 1,2 newtons.
1, comma
2 newtons. Yes.
Now, here is where our term 1 struggle causes more struggle. If net would be the root of the 0.864
Oh,
squared plus
1.2
1.2 squared.
Yes.
1,48.
And there is no sense in doing this without getting the direction. So the angle between the two.
It's 1,49. I mean 1,48. Okay. But where is this? It's the one in the
Dad is opposite Jason's.
Hmm?
Sorry?
55 degrees.
55 degrees east of 90.
No, you can't say east. But I can say 55 degrees with respect to force 2 on 1.
Yeah.
54.
Oh, you're calculating this angle then. Right.
WTR.
With respect to.
Now, why did you say with respect to F2 on 1?
Because that's the angle I've calculated. It's the angle the net force is making to the force of 2 on 1. I did not calculate, I calculated that angle there. I did not calculate this angle here. If I calculated this angle here, I would have also got my marks, but I need to say it's with respect to the force of 3 on 1.
Would you get the same marks? I mean,
Yes, because it's correct. This angle will be 90 degrees minus the 54.25.
if I say with respect to F net, that also fine.
No, it's not with respect to F net. It is the angle of F net with respect to the force of 2 on
So
1.
if you said 90 minus that, you'd have it with respect to 3 to 1.
Yes. If you swap the 1.2 and the 0.864 around, it would have been giving you the angle with respect to force of 3 on 1.
Yeah, because your feet